So the question is, how small does it get? Does it become 38 or does it become 32 or 30 or 20 or 2 or 1? Well, any guesses? How big is this angle right here? 20. That's a great guess. And you're right on. That's what the answer is. But in the best form of geometry, we should prove that. So here's the way we're going to prove it. I'm going to draw that again. And I'm going to draw myself a central angle knowing that this is X. I don't know what that number is, but I don't want to use 40 because then I'm only proving it for 40 degrees. I want to prove it for all degrees, so I'll use a variable. And if that's X, we know that this central angle is X. Now I'm going to pick something over here, maybe there, and I'm going to connect it to both ends. And I've purposefully tried to make this a little bit closer than this. It's not perfectly pulled back because, again, I don't want to only set up a proof for something that is a special case. And now what I'll do is connect that. I don't know what this angle is, and I don't know what this angle is, but I do know that all three of these angles together, A plus B plus X, adds up to how much? 360. It goes all the way around in a full circle, so that part's 360. You guys okay with me for that? I'm just going to leave that alone for a second. Now, this red segment goes from the center of the circle to the edge of the circle. We call that the what? Radius. And this one also goes from the center to another part of the circle, so that's also a radius, which means these two are the same length because they're both the radius, which means this triangle is what kind of triangle? Very good. It's an isosceles triangle. And if it's an isosceles triangle, then we should be able to find the relationship between these two angles. They're going to be congruent. And I want to express them in terms of B. So let's do a little kind of going off on a tangent here for a second. And let's say that if this were, I don't know, 100 degrees, and I told you this was isosceles, would you be able to find these two angle measures? How would you do that? You'd take 180 and you'd subtract that 100, and then you divide that by 2. And that would get you 40 for each of these, right? So can we do the same thing with this one? We can say that this angle here is 180 minus B over 2. And this one is also, right? Not very pretty, but it's right. And then can I do the same thing here? Because this is a radius, and so is that. So how much is this angle? Good, 180 minus A over 2. Now what I'm interested in doing today is coming up with a formula for this whole angle, which means it's both this part and this part. So I'm going to write it as 180 minus A over 2 plus 180 minus B over 2. And since these are both fractions, but they've got a common denominator, I can combine them into one big fraction. Which means I can combine like terms. 180 and 180 is 360. And minus A and minus B, I'm going to call that minus A plus B. That's the same, isn't it? All over 2. Okay. Now the problem was I wanted to find this in terms of X. Nick's hypothesis was that it's half of X, right? When this was 40, this was just 20 degrees back here. So he was expecting this to be X over 2. I've still got this A and the B in the way. It'd be nice if I can get rid of that. Ah, look at this. I've got another formula with A, B, and X. I want to solve for A plus B. So I'll subtract x from both sides. And I get a plus b equals 360 minus x. Now, if I replace this a plus b with what a plus b is now equal to, I get 360 minus x over 2, which becomes 360 minus 360 plus x over 2, or x over 2. That's a formalized proof. I didn't do it in a 2-column format, but theoretically, if we were doing a really rigorous geometry, we'd be doing that for every single theorem. But what that ends up with is an idea that anytime I've got a circle and I take an angle all the way from the corner here, from the edge of the circle, and I draw it across, whatever value is over here is going to be exactly twice the value that's over here. So this is 1/2 of x when this is x. From that, we can derive a couple of cool little extensions. One is, what if I were to draw another inscribed angle that ends at the same points? How much is that? Maybe we should use numbers instead of our variables here. Let's say that this is 100 degrees. How much is this angle over here? And how much is this one? 50 also. Isn't that just another one of these things? It's another inscribed angle. And if I did it from here, that's also 50. Now, one of the things that messes with people here is, which angle are we talking about? Which arc are we talking about? So here's what I suggest you think about. Pretend that this point, the vertex, is the head of a flashlight. And if you were to shine the flashlight, it shines all the way out here in a beam. And what that shows you is the arc that it intercepts. This is the arc that it intercepts. So that's the one that we're going to be dealing with. And if I shine from the 50 degrees over here in the green, doesn't it shine on the same spot on the wall? So it's going to be the same angle. And even this last one here from the red, it shines because of the endpoints to the same spot on the wall. As a result, it's going to have the same angle. These are all called inscribed angles. And as you can see on the top left board over there, it's just a specialty case of our inscribed angles. If you have multiple overlapping, they're going to have the same measure. Here's another specialty case. This is one of my favorites. If I have a diameter, how many degrees are in this semicircle? 180. And so if I pick any point on the other semicircle and use that as the vertex of an inscribed angle whose endpoints are the end of the diameter, how big is that angle? 90 degrees. In other words, no matter which point I pick here, it'll be a right angle. Any point I pick will be exactly a right angle. Come on, isn't that kind of cool? Like if you're stuck on an island somewhere, a desert island, and you need to make a right angle, you would say, if I had the center of a circle, I'd pick any point on that circle and draw straight through that center, making a diameter. And then I get to pick any other point and connect it to the endpoints of that diameter. And what type of angle did I just make? A right angle. I think that's cool. Maybe that's what makes me a math teacher. All right, the last one for us today is, what if I take a circle and I inscribe in it, in other words, draw so that its vertices are all on the shape, a quadrilateral. And again, I'm purposefully not making it like a square or a rectangle or a rhombus or a kite, because I don't want this to be just a specialty case. I want it to be for all quadrilaterals. So let's say I know that this is 80 degrees here, and I know that this is 120 degrees here. Any ideas how we could find the other two angles? Okay, good. You know they add up to 360. So far we've got 200, so they're going to add up to 160, but is it 60 and 100? Or is it, what did I say, 160, 90 and 70? Or is it 80 and 80? Yeah, and then we'd have a problem because then that would make, well, no, because they'd have to be, yeah, if three of them were congruent, that wouldn't necessarily be a problem. I was thinking about parallel lines and alternate interiors and such, but these are same side. So they'd have to be supplementary. But let me ask this. If this is 80 degrees, is it an inscribed angle? Like the ones we've just been talking about today? Yeah, its vertex is on the circle. So if I go to the endpoints of that angle and draw an arc, if this is 80, how big is this arc? It'd be double that or 160, right? And yes, the picture's not quite drawn to scale. And then how much is left for that? Good, 200, because the whole thing is 360, right? So if I take 360 minus 160, I get 200. And does that then tell me how big this angle would have to be? Yes. It does. If that's 200, how much is that? 100. And do you notice that these two angles opposite each other together intersect arcs that make up the full circle? So if they have to be half of those arcs, together they have to add up to 180. So if this is 120, how much is left for this one? 60. Okay, so these are our theorems for today. Let's formalize it, put it into your notes. Does everybody have a packet? Everybody got a pencil? Okay. First one, an inscribed angle is an angle with a vertex on. Need a pencil? Yep. With the vertex on the circle, with two sides that are what? No, they don't have to be congruent. They're not radii this time, chords. The intercepted arc is the arc that lies between the whats of that inscribed angle. Little more than points. What kind of points? End points of that inscribed angle. And the measure of the intercepted arc, of the inscribed angle is half the measure of the intercepted arc. Put a 1/2 there. And that way, in this example, we see that the measure of ABC should equal 1/2 the measure of arc AC. And then we have two of the specific circumstances here. This is my desert island idea, that anytime an inscribed angle meets a diameter, it has to form a right angle. such that the measure of BAC would equal 90 degrees. And then this overlapping idea, if two inscribed angles intercept the same arc, so for example, ABD. So here's an angle, ABD. And then if I were to see which other angle intercepts that same arc, it might be that angle. So those angles would have the same measure, ACD. And notice the endpoints of this are A and D, and the endpoints of this are A and D. You would expect that to be true. These angles will be congruent. Say again? Okay. So let's apply some simple examples here. If we know that this arc is 62 degrees, then the angle that's pulled all the way back to the edge of this circle, this little angle down here, WXY, is an inscribed angle. So what would be its measure? Yeah, it would be 62 over 2, which is 31 degrees. And of course, they could try to throw a curveball at you. Here's where they give you the angle and they ask you to find the measure of the major arc. So instead of dividing it by 2, what would you do? Yeah, just multiply it by 2. So that would be 226 degrees. What about PQR? Good. That's a 90 degree. That's my little desert island problem because the endpoints PR make up a diameter. All right, let's go to number 6. RST. First of all, is that an inscribed angle? Yeah, S is on the circle. And I can see here the arc that it meets. I just don't see any value on that arc. How could I find that? They give me all these other ones. What do you think, Hillary?
We know that the arc S will figure from that one is 139 because it's an inscribed angle, and then you can do 180 minus.
I think, let me think about that. 180 minus 39.
No, I meant like it goes to the other, not 180 minus 139, but you can pull it back. I mean, like you divide by 2. Yeah.
It's true that you could get angle T here to be half of 139,
Yeah.
but we're looking for RST. We want this one down here. So first we have to find this arc. What do I know about all the arcs around a circle? They equal 360, don't they? So if I said 64 plus 139 plus 75 plus the measure of RT arc, this little one here, that's equal to 360. So that means that 278 plus the measure of RT equals 360. So the measure of RT is equal to 82. Okay, so now we've got this arc. If I know that's 82 degrees, how big would the inscribed angle be that meets that? Good, 41. And now it's acting like it's a whole nother problem all over again. RUT. How can I find that angle?
That not also.
It is, right? Because it meets the same arc over here. So this is that overlapping arc idea. Any questions on inscribed angles? Okay, please, you're going to go back and do page 2 as your homework, but we're going to do a little instruction on page 3. And again, this is the one I taught you beforehand. If a quadrilateral is inscribed in a circle, then its opposite angles add to 180, which means we claim that they're supplementary. In other words, in this circle, we can say that A and C are supplementary. So the measure of angle A plus the measure of angle C equals 180. And these two also. And the measure of angle B plus the measure of angle D also equals 180. So let's do a simple one here. If M is 45 degrees, which angle is opposite it? Good. So K plus 45 has to equal 180. So K equals 135. And then L and J are opposite each other. So we could say that J plus 92 equals 180. So J is 88. Lemon squeezy? What do you think? 5. I think I do understand this stuff. I'm going to do this just fine. 3, I'll need to look at the notes. Unfortunately, they're up on the board in the upper left there so I can see them. 1, I'm not sure I understand this stuff. Okay, good. And I'm going to have plenty of time to circulate to give you individual help. Please flip to the very last page. It says the giant circle challenge. I want you to fill in problems measure 1 through measure 21. Nice groaning. It was almost in sync. Can you guys like harmonize or anything? You'll find that these aren't so bad once you get into them. What I do want you to do is call me over when you're done so I can tell you right or wrong, give you direction. And then when you finish this, you can get started doing the homework. And the homework will just be to finish this, pack it up, and submit it. Any questions?